good morning to all of you. Today we will start a very important topic, that is electromagnetic induction. Till now we have been studying magnetic fields produced by current carrying conductors, forces between current carrying conductors, and so on. So, remember I had shown you a demonstration which Hans Christian Ørsted had done in 1820 to show that currents produce magnetic fields. Current carrying conductors produce magnetic fields. And then we studied magnetic fields produced by a straight current carrying conductor, magnetic fields produced by a solenoid, and so on. Now, today what I am going to discuss is a very important topic in electromagnetics, and that is electromagnetic induction. So, when it was shown that electrical currents create magnetic fields, the obvious question that arose is, can magnetic field produce currents? Can magnetic fields produce current? That means, can I use a magnetic field to generate current? So, a lot of experiments were carried out by many scientists by placing very strong magnetic fields, magnets around conductors, by passing current through conductors close to another conductor, and they did not find much successful results in generating currents, until Michael Faraday in 1831 did a series of extraordinary experiments to show that to generate current I need a changing magnetic field. Something should change, and that change will result in an electrical current. Now, Michael Faraday was a very famous scientist, British scientist, and he has contributed significantly to electromagnetics, electrochemistry, and so on. He lived in the period Michael Faraday (1791 to 1867). So, he did some outstanding experiments in electromagnetics, and also electrochemistry. He also studied diamagnetic properties. He was an excellent experimentalist. And in fact, Albert Einstein had a picture of Michael Faraday in a study room, along with pictures of Sir Isaac Newton and also James Clerk Maxwell. We will study about Maxwell's equations later on, but Michael Faraday was a very important scientist in the development of electromagnetics. And today what I am going to show you is some experiments similar to what Michael Faraday did at that time to show relationship between magnetic fields and currents. We have till now studied that currents produce magnetic fields. I will now show you that it is also possible to generate currents using magnetic fields, but under certain situations. So, let me first show you a solenoid which I have wound by taking a piece of copper wire, and here is a solenoid, and these are the two ends, and you can see here there are windings around the solenoid, and this solenoid, as you know, can create a magnetic field. So, this is one solenoid, there is another solenoid here which is a smaller solenoid, and that has a larger number of windings, and I want to show you that this solenoid will produce magnetic field. So, what I do is, here is a compass, which which contains the north and south poles, and I connect this solenoid to a battery, and you can see immediately the magnetic coil is rotating. Then this particular solenoid generates magnetic field. So, this is essentially an experiment to show that currents generate magnetic fields. Now, I want to see whether magnetic fields can generate currents. Now, before that I want to show there are two permanent magnets here which I had shown in an earlier experiment. these are two permanent magnets, very strong permanent magnets, and as you can see here it has a very strong effect on the needle. So, this is a soft iron piece, a larger number of pieces of soft iron, and this is formed into a cylinder here, a large number of pieces, and this particular piece I connect to a magnet. The moment I put a